Hi, this is Team 52. We are presenting a cross-lingual font generator. Font generation is a very laborious and time-consuming process because of complex structure of characters, serif details, artistic style, and texture. It is not an easy job to maintain a coherent style across all characters of a font for writing systems which are not alphabetic, like Chinese. For example, there are over 20,000 unique characters in Chinese official character set. So our aim in this task is using a few samples to automatically generate font with artistic style and construct a neural network to accomplish it. Of course, researchers have developed various of style transfer GANs for fonts. Most of them focus on generating fonts using the same language. However, a modern font library doesn't only include one language, but also others. So we developed a generative model which can generate fonts within the same language or a different language based on GasNeXt and font translator GAN. We re-implemented GasNeXt and improved font translator GAN by adding a local discriminator, made it be able to transfer colorful styles. So one of the datasets we used is from GasNeXt, which includes most common used glyph images and colorful texture styles for Chinese characters. For Latin letters, we leverage the dataset used in MC-GAN. And we have datasets from font translator GAN to do cross-lingual style transfer. All of them are pre-processed to fixed size images. Regarding our architecture, we leverage the idea of layer attention and context-aware attention modules in the generator of font translator GAN. The context-aware attention network captures the local style feature, while the layer attention network captures the global style feature. They work together to make our generator more flexible when dealing with arbitrary font styles. To be more detailed, in the context-aware attention network, we introduce a self-attention module to make the new feature contain both the information in their receptive fields and context information from other locations. We follow the instructions in the original paper to use 3 parallel context-aware attentions. After having local features and the global features, we apply a layer attention to select which feature level the model should focus on by assigning scores to them. After that, we take them in and expand the encoded style features.
Now we will talk about our model GasNeXt. Our architecture is very similar to that of FTransGAN, except that we added a third local discriminator, inspired by GasNeXt. This discriminator takes in the real and fake data and cuts them into random small patches, then blurs the images and tries to differentiate the real and fake ones. The advantage of adding this discriminator is to improve the knowledge of our model on detailed parts of the style, in addition to the style as a whole. For our results, we have achieved a similar level of metrics as stated in the FTransGAN paper for our re-implementation of the baseline model. The evaluation metrics of our model is still running as we speak. These are a few of the selected examples of our character generation compared to the baseline and the ground truths. As we can see, in the emphasized region in circles, our model is able to perform better than the baseline. These are actually parts of the characters where the more traditional fonts of Chinese calligraphy are curved, whereas the target style is sharp-edged. Our local discriminator allows GasNeXt to better adapt to the style compared to the baseline. In styles where there's less modification of sharpness, the two models perform similar, as we can see on the right. We have also attempted to add color feature adaptation to GasNeXt, but have not achieved great results yet. This is an implementation by passing in the RGB channels of the target style independently into our trained model for testing, as our model is trained on grayscale. The obtained result is non-ideal, as we later found that the differences in generated pixel of each channel can lead to poor results, as we can see on the right. In conclusion, our model features both monolingual and cross-lingual font style transfer and generation, with a potential improvement on Chinese fonts featuring sharp-edged style. For future work, we will finish on the GasNeXt evaluation metrics. There can be more targeted experimentation on Chinese fonts featuring sharp-edged style to validate our results, and improvements on color style transfer feature. Thank you.